Hello friends, in this video we will learn impulse signal. Let us begin. So let us start with impulse signal here. An impulse signal is a short duration signal with a finite amplitude here. So I can write f of t, what is given in the figure, like this. F of t value, as you can see, it is equal to k. But at what time? As you can see, it is present at t equal to 0. So I can write f of t equal to k at t equal to 0. Otherwise, if you see, this signal does not exist when t is not equal to 0. So this area which I am saying t greater than 0 and this area which I am saying for t less than 0, f of t is having value equal to 0. So I can write f of t value equal to 0 when t is not equal to 0 rather than specifying t greater than 0 as well as t less than 0 separately. So this is what we actually called as a impulse signal. Let me tell you frankly, impulse signal we cannot have it practically, because how can we really assume some signal which is present only for 0 time? I mean, duration of the signal can be less but it cannot be 0 for sure, am I right? So practically this impulse signal can be seen as a sudden noise signal which occurs from nowhere for short duration of time. Practically duration of the signal cannot be equal to 0. So if I want to go for a practical impulse signals, then let us understand how this practical signal looks like. So this is a practical version of the impulse signal. As you can see, I'm not going to play with an amplitude of the signal. Amplitude of the signal is still same, which is equal to k, but it is having a finite duration now. Rather than saying 0 duration, I'm having some practical a short duration. So as you can see, it is evenly distributed over time t equal to 0. So therefore it is starting from minus a by 2 to a by 2. Am I right? Now the question is, what characteristic of the signal is important to me? I mean, the amplitude is important to me or a duration is important to me. So this is a duration. Okay. So this is whole duration. Here duration is equal to what? A. And height of the signal or amplitude of the signal, it is equal to a. So far, when we have studied step signal, as you can see, in step signal, what is important, amplitude of the signal is important. Here, in this case, which we are learning a new signal called as impulse signal, height is k and duration is a. Because as we have seen, theoretically duration can be 0, practically duration cannot be 0. Practically we can assume the width is minimum. So duration is also important and height is also important. Now to make it only one characteristic, we take area of the signal, because as you can see, practically it is just a rectangular kind of signal, am I right? And when it is a rectangle, you can calculate the area by using length into breadth property, am I right? So what is the length here? Length is k and breadth is a. So length is k and breadth is a. So I can write area equal to a into k. Is that right? So let me tell you, the property of impulse signal is taken in terms of area. Okay. Property of step signal is always taken in terms of its height or in terms of its amplitude. But when it comes to impulse signal, we always assume or we always look at the characteristic, that is area, because it covers both, that is length as well as breadth of the signal, that is height of the signal as well as duration for which it does exist. In terms of step signal, we always look for an amplitude, but when it comes to impulse signal, we are not concerned only for amplitude, but we are also having a concern that for how much duration this signal does exist. And as I said, to incorporate both, we take area. So we always look for an area. So when it comes to unit impulse signal, okay, when it comes to unit impulse signal, because it is just impulse signal, which is generalized impulse signal. So when I'm talking about unit impulse signal, it is a signal which will have area equal to 1. Similarly, when I'm talking about step signal, okay, so it can have any amplitude, but when I talk about unit step signal, it will have amplitude equal to 1. So we know that when amplitude equal to 1, talking in this context, when amplitude equal to 1, the resulting signal is called as a unit step signal. Am I right? In this context, I can say when area equal to 1, I can say it is unit impulse signal. Is that right? So let us understand what is exactly meant by unit impulse signal and how it really looks like. So let us understand unit impulse signal. A unit impulse signal is such a way that area should come out to be 1. Is that right? When I say area, it is nothing but L into B. So the length was K and breadth was A should be equal to 1. Now, you know what I'm interested in? I'm interested in how much should be the height of the unit impulse signal. In that case, I can say height is K. So K is equal to, I can write this as 1 by A. Is it right? So this should be the height of signal if you want area to become 1. So I'm drawing that unit impulse signal again. So started with minus A by 2, ending at A by 2, which makes width equal to A. And height, as I said, it should be 1 by A. Is that right? So one thing is quite sure, that area is always 1 for unit impulse signal. What does that mean? Suppose if you expand this width, then height must be reduced. Is that right? So as to keep unit area. Or let's say if you have reduced this width, then it must give you the higher height. So if you have reduced the height, or if you have reduced the width, then it should give you more height, so as to keep area equal to 1. So this is the requirement. If you reduce the width, then height will increase, and if you, let's say, increase the width, then height will be reduced, so as to keep area equal to 1. But we know that we have already studied the definition of impulse signal. It is a signal which will have a very short duration signal. Theoretically, in fact, width should be equal to what? 0. So theoretically, we know that width should be equal to 0. Now, if width equal to 0, can I say that in our case width is A, then A should tend to 0. If A tends to 0, which is considered as width, and we know that since we have unit impulse signal, our height accordingly is 1 by A, then 1 by A becomes 1 by 0, so height should be infinity, or height should tend to infinity. So if such signal, if I try to draw, then I'll get such type of signal which I'm drawing now. This is T, I'm writing it 0, and what is the height now? Height has become infinity, am I right? Height has become infinity. But we know that we always designate our impulse signal not with the help of height or width, we designate with the help of area. So hypothetically, area is still equal to 1, so generally we write 1 here. And let me tell you, delta signal is denoted by a special symbol or special letter, that is del of t. So del of t is called as a unit impulse signal. Remember that unit impulse signal is written as del of t. So now let me write this del of t is having value equal to infinity at t equal to 0, and it is absolutely 0 when t is not equal to 0, that is for t greater than 0 as well as for t less than 0. So we write this magnitude wise. So what property I have written over here, it is magnitude wise or amplitude wise. So this is true when I write it amplitude wise. Now if I want to express the delta signal area wise, because as I said, in case of impulse signal, the property which is important is not for how much duration it is present or for what height it is present. It is required that height as well as width both should be incorporated. So area is important to us. So how much is the area? Area is equal to 1. So in the textbook you must have seen they write del of t equal to 1 at t equal to 0. So what I said, they write like this: del of t, it is equal to 1 at t equal to 0, and it is equal to 0 when t is not equal to 0. So this definition of del of t is true area wise. So if you studied area wise, then del of t should become 1. Remember, 1 is not height, 1 is an area. If the area becomes equal to 1, then the resulting impulse signal is termed as unit impulse signal, denoted as del of t. So I'm sure you got the clarity on this delta signal. So let us go on discussing this delta signal or unit impulse signal in detail. So when I'm talking about a generalized impulse signal, then it would be like this: a del of t, like this. In this case, as you can see, coefficient of del of t is a, then a is considered as area of that signal. So to understand this, first of all, I'll talk about del of t signal. What was del of t signal? We know that del of t signal is called as unit impulse signal. Now the question is, why it is called as unit impulse signal? Because it is the impulse signal having an area equal to unity, or it is equal to 1. So tell me, suppose you have some information graphically present, and for that particular curve, if you want to take the area, which mathematical tool you use? Of course, we use an integration, because integration gives you area under the curve. Suppose if I integrate del of t with respect to time from minus infinity to infinity, then what you will get? You know that every integration gives you area under the curve, and area under the curve of unit impulse signal is of course unity. So I can say this is equal to 1. So this is a very important definition of del of t. So don't forget that whenever you integrate del of t over minus infinity to infinity, it is always equal to 1. Now the question is, why to integrate the curve over minus infinity to infinity? So this is just the in generalized expression or in generalized lower limit and upper limit for a particular signal, because most of the time we may have curve graphically present, but we don't know what is the lower limit of the curve and what is the higher limit of the curve. So it is essential we always go for the generalized lower limit and upper limit, which is from minus infinity to infinity. So therefore I have integrated del of t over minus infinity to infinity. Understand, integration gives you area under the curve, and we know that area under the curve of unit impulse signal, it is equal to 1, and that's the reason why we call that impulse signal as a unit. Okay, so unit word is very important because it is having area equal to 1. We have another signal, let's say 5 times del of t. 5 times del of t. Let us understand what is the meaning of it. So to understand it, what I'm doing, I'm integrating 5 del of t with respect to time. So if I integrate minus infinity to infinity 5 times del of t dt, we know that 5 is constant, so obviously it will come out. So what we have over here left is minus infinity to infinity del of t dt. And we have already studied that area under the curve is always equal to 1 in case of unit impulse signal. Therefore, this integration which I'm highlighting, it will give you value equal to 1. Ultimately, what you get answer as 5. Moral of the story, when you have coefficient equal to 5, I can say that it is an impulse signal with area equal to 5. That's the reason why what I was claiming over here, when I have a dot del of t, that is a is a coefficient of del of t, so it is impulse signal with area equal to a. Here, since I write 5 times del of t, it means it is an impulse signal with area equal to 5. Because ultimately when I am integrating 5 del of t dt, what integration gives you? It gives you area under the curve. Please don't forget that. So what answer you are coming across, it is equal to 5. It clearly means 5 times del of t is an impulse signal with area equal to 5. So let me just summarize. Whenever you write a times u of t, what is the significance of a? It's very clear that significance of a is nothing but a is amplitude. So what a here is, it is an amplitude. Is that right? Suppose let's say you have a times del of t. So what is the significance of a here? Okay, in both the cases a is coefficient. But in both the cases, A means something else. In first case, when I say A times u of t, A is an amplitude. And when I say A times del of t, then A is, even though it is a coefficient, here A means area of the impulse signal. Now the question is, in case if the area of the impulse signal is changing, what does that mean? Is it changing the height? Answer is no. It is not going to change the height. In fact, height is going to remain infinity. Is that right? Height is going to remain infinity. What's the reason height is going to remain infinity? Because it is a short duration signal. Is that right? Because it is a short duration signal. So height is not going to change. Only area is going to change. Is that right? So now to give you a clarity, I can take the same example, which is 5 times del of t. So now I'm going to write del of t, or I'm going to define del of t magnitude wise or amplitude wise. So if you remember, we have already written like this: unit impulse signal del of t is always equal to infinity at t equal to 0, and it is equal to 0 when t is not equal to 0. Am I right? Similarly, suppose if I write now 5 times del of t, 5 times del of t. So we know that original del of t is having an amplitude equal to infinity, which is now getting multiplied with 5. So I can write like this: 5 times infinity at t equal to 0, and it is equal to again 0 for t not equal to 0. So what does that mean? When I'm saying amplitude wise, when infinity amplitude gets multiplied with 5, do you really think you'll get some other height? No. So remember, even 5 times del of t is also tending to infinity amplitude wise at t equal to 0, and it is equal to 0 when t is not equal to 0. So that's what I'm actually trying to claim, that A times del of t is not going to change the height. It is only going to change the area under the curve, that is impulse signal. So I'm sure now you are quite comfortable with this impulse signals. Thank you.